In this video, I'm going to show you how to install a 240 volt outlet that's going to be used for an EV car charger, and these same principles can be used to install an outlet for a welder and even an electric range. And if you're new to this channel, my name's Josh. It's all about DIY to save a ton of money, so be sure to subscribe, ring that bell so you get notification every time I release a new video, and hammer that like button for me. That's all I ask in return for making this video. So we're going to hit the whiteboard first so we can go over some details. So let's get started. I first like to explain to you what a 240 volt outlet is and what the circuit consists of. So first of all, 240 volts in America can also be referred to as 220 volts depending on who you talk to. So these can be used interchangeably across the United States. And also, if you need to get 240 volts, we got two different breakers here. We got a double pole 50 amp breaker here, and then I got a single pole 20 amp breaker here. So with that being said, this can be used to draw 110 or 120 volts depending on who you talk to. Again, that's used interchangeably as well. So this can be used for the 110 single pole, and then we got a double pole breaker here. So this is more or less, you can think of it as two single pole breakers in one. So this is going to draw 240 or 220 volts depending on who you talk to. So this is something I wanted to explain first before we get started to save the confusion. For this installation, I'm going to be using a NEMA 1450 outlet. So with that being said, what is NEMA? NEMA stands for the National Electrical Manufacturers Association, and you can think of the numbers behind the NEMA as a code in which you describes the environmental protection, what the circuit's used for, the outlet's used for, etc., and how the outlet's built. So that's something very important to note while I'm talking about the different 220 outlets. So with that being said, what I'm going to be installing in this video is the NEMA 1450, and these outlets are typically used for EV charging, RVs, ovens, which are ranges, and this can be used with a 6-3 wire. So what is a 6-3 wire? Well, a 6-3 wire is going to have three conductors, a red wire, a black wire, and a white wire with a ground. So there's a total of 4 wires, but it's called 6-3 wire because we have 3 conductors. So with that being said, that's what's going to be installed in this video. And next, we want to talk about if we're going to run a 220 volt or 240 volt for a welder. So typically, welders require a 650 or a 1050 NEMA outlet, and these can be used with either 6-2 wire or 6-3 wire depending on the welder. So always check the manufacturer of the welder and what they recommend before you install your outlet or the circuit for your outlet. So that's a very important concept to note, but the installation of the circuit itself as far as running the wire and the 50 amp breaker is going to be the same as what we're going to do today. So you got to check your manufacturer to see what type of outlet and what type of wire you're going to need for your welder. So that's just a quick rundown on if you're going to use for welder. Now, I made a video in the past, you can check out the link at the top right hand corner of the screen, and I installed a NEMA 1430 for an electric dryer using a 10-3 wire. And just a quick note when it comes to the NEMA numbers, the end number is typically the max amperage in which that outlet can handle. So for instance, this NEMA 1450 can handle up to 50 amps with a 50 amp breaker, and then the NEMA 650 and 1050 can handle 50 amps on a 50 amp breaker, and then the NEMA 1430 can handle up to 30 amps with a 30 amp breaker. So with that being said, I'm going to show you the technicals on how I'm going to wire my NEMA 1450 outlet for the EV charger. I'm now going to show you the supplies that I got here to wire up this 240 volt outlet. Now, I want to point out right off the bat, this receptacle is for a range. It's a lighter duty one made by Leviton, and I've got one that's going to be for the EV charger that I'm going to be installing in this video. But I just want to point out there's different grades of these, and I'll explain more about that here in just a minute. But when this comes out of the panel, we're going to have a 50 amp breaker going to a 3/4 inch Romex connector, and then it's going to secure the wire out of the panel to this 6-3 wire. And then we're going to secure the 6-3 wire using these 9 16 inch wire staples. And then it's going to run over to this 2-gang metal box, and it's going to be secured using another 3/4 inch Romex connector. And then I got a green ground screw that's going to be used to ground the wire to the 2-gang box per code. And then we got 2 different mud rings here. I got both, so I wanted to show you the difference. This is the mud ring I'm going to be using because I'm going to be ultimately doing a flush mount. The outlet will install right over that, lining up with the holes, and then the plate cover will go right over that, flush with the drywall. But if I just had it running to metal conduit, I'd just use this cover and then it would be installed like so, and that would be the finished product. But because I'm in a finished drywall garage, that's why I'm going with this mud ring, and it also adds a little more space in the 2-gang box. So I just wanted to go over all this before we got started. Also, I'll put a link in the description below to check out all these products for yourself. Something really important I want to make sure you're aware of, after I set the 2-gang box and run the 3/6 wire to the panel, I definitely got to install the drywall next before I install the outlet and mud ring and the cover and all that. But I just wanted to show you how the rough end's done first, and then what it'd be like after the drywalls to make this video complete. So with that being said, you always install that mud ring and the outlet and the cover after the drywall's up. Before we get started, I'd like to mention, always check your local building codes and be compliant. Check your manufacturer's recommendation of all your devices and make sure you install them accordingly. And definitely don't do any electrical work if you're not comfortable with it. I have done plenty of wiring myself and wired my own building, so I have lots of experience. And definitely hire a professional if you have any questions or concerns. So I'm going to begin by running my 6/3 wire from my panel over towards where I want the outlet to be installed. All right, I now have the other end of that 6/3 wire, and I'm going to be placing this outlet here towards the entrance of the garage. Right here's my garage door. Here is the back end of my garage. And the reason why I'm doing that is because if I pull in, the EV charger is going to be located here on the wall, and that way I can plug the charger into the back of the car. But that's not the case with all of them. There's several where it's on the front or even the sides. So if you're wanting it closer to your charger port, be sure to check the vehicle that you're interested in or the one you have. I now have my drill with a 3/4 inch drill bit in order to drill out through the top plate to get down to the stud space to install the 2-gang box. Because I'm going to be coming down beside this stud, I'm going to stay about 1.5 inches away from that stud and drill in the center of the plate to enter into this bay. I'm now going to fish the end of that 6/3 wire down into this stud space. I'm now going to prepare the 2-gang box to be installed. I'm going to go ahead and place this Romex connector here. And I'd like for you to note, at the top we have a place for a 3/4 inch connector to go in here. Then there's one here in the middle, one here on the left, one here in the middle again. So we want to come in through this side because right here's where the stud's going to be located. So I'm going to knock this out using a punch and a hammer. Now I'm just going to use my linemen's to finish off that knockout. And now in order to install the 3/4 inch Romex connector, I'm just going to take off the lock nut and then fish it through so that the ends for the square drive is facing out. And then I'm going to reinstall the lock nut onto the box. Now we're ready to secure this to the stud. I'm now going to measure up 3 foot off the floor and make a mark. And I'm going to make this the bottom of my outlet. I'm now going to mount this 2-gang box flush with the stud, so that way once the drywall's on and the mud ring's on, it's going to be flush with the drywall. And I'm just going to take construction screws and screw those into the side to secure it to the stud. I'm now going to install a 2x4 block in behind this just to give it a little extra security. Since this is new construction, I got this option, so I'm going to do it. All right, that box is super solid now. I'm going to fish the 6/3 wire into the box via the Romex connector. And I want at least 6 inches sticking out past this stud. So I'm going to go ahead and tighten up that Romex connector using the square drive. I'm now going to take a utility knife and go over this wire real light and take this black jacket off and remove all the paper off the ground wire and get rid of this black jacket. I'd now like for you to take note of this hole that's sticking into the box. It's meant for the green ground screw, so I'm going to go ahead and place that into that hole. I'm now going to take the ground wire and I'm going to loop it around in a way that it goes flat against the back of that dimple, and then I'm going to tighten it down. Now that the copper wire is looped around that ground screw, I'm going to tighten it down very snug. Now the box is grounded, and that is a very important step to this process. I'm now going to install this mud ring that is designed for the flush mounting. So this is very simple to do. I'm just going to fish it right over these wires. And then we have a screw here and a screw here. We're just going to loop them right into them like so. I'm now going to tighten up those screws. Before I wire up the 50 amp outlet, I want to explain to you the 3 different types of outlets that I was going to choose for this install. And I'm going to show you why I went with one over the other. And all 3 of these are 50 amp and all 3 of these are NEMA 1450s, but there is one key difference that I wanted to explain to you. This outlet and this outlet is designed to be flush mount, and like I explained already, I'm going to be doing a flush mount, so that eliminates this one right off the bat. This is a surface mount outlet, and what this would be for is if I was going to stub up through the floor and anchor this behind the range in order to have it installed if I didn't install the flush mount. I try not to do this. I always try to install flush mount for ranges. And just while we're on the topic, if you open up the surface mount, if we take a look inside, if we unscrew this straight screw, what's inside are all the areas to anchor the wire to, as you can see here. And we're actually missing a lug here for the white wire. It must have rattled out and fell out. But as you can see, this was where the white wire would go if you had the lug. We have the green screw for the ground, and we have the 2 for the hots. And these would be torqued down the specs if you were to install a flush mount. And then you got a clamp here that's going to hold the 6 wire into place. So I'm going to go ahead and remove this off the screen because, as I just mentioned, this will not fit my flush mount idea. So now I'm left with these 2. So we got a big price difference here. This one cost almost $100 and this one only cost $10. This one's made by Leviton. This one's made by Hubbell. This is a 1450 and this is a 1450. But the key difference that I noticed to this one is like an industrial grade outlet, and this one is more of a residential lightweight. You can tell it's lighter built. This one's heavier built. This one's going to be great for unplugging and plugging in items, so you don't have to be stuck with just one plug-in. So for instance, when I plug a range into this one, it's not built real heavy to where you can unplug and plug in different items like I'm going to be doing with the EV charger and other items into this. And look at the back here. These are definitely different, as you can see. If you take a look, this is Allen screws that's going to be holding, or Allen terminals that's going to hold down the wire. And these are simple square drives, and it's not near as deep and heavy built at all compared to this one. So the Hubble outlet is going to be what's recommended for EV charging level 2. So this is going to hold up well over time, and you're not going to have any issues with this using it for EV charging and other uses. And I'll put a link to this in the description below along with the other ones as well. So if you want to check those out, go ahead. Another difference between these 2 that I'd like to point out is the face. The circumference of them are different. The cheaper one has a smaller diameter compared to the more expensive Hubbell. And the plate cover that's designed to go on the Hubbell is a little bit heavier built. And again, this is going to be something you'd purchase with the Hubbell. And then the Leviton, as you can see, is a little smaller. It goes on and it will not fit onto the Hubbell. So that's something to think about as well. Of course, that's not a cosmetic importance, but it's something I wanted to point out. Now we're going to go ahead and install this into that 2-gang box. I'm now going to trim these wires down so there's not an excessive amount sticking out, so they'll all fit in the box after I install the outlet. And clearly, because we are just running this wire now, we know there is no power to it, but if there was a breaker hooked to this, make sure the breaker is off before connecting the outlet. I'm now going to strip the sheathing off the ends of the wires to make my connections to the outlet. If we take a look at the back of the outlet, as you can see right here, we got a strip gauge, and if we hold that up to the wire, it looks like we need to strip off just about a ½ inch or so in order to make the connection correctly into these terminals. In order to do so, I'm just going to take my utility knife, go right around the insulation here lightly, and just go till we score the sheathing really well, and then we're going to cut straight down it like so, and then we'll peel it right off. We're going to do that to each one of the wires. I'm now going to connect the wires into the back of this outlet. And if we take a look at these terminals, we got green is what it's labeled, then we got white, YYY, then XXX. The white's going to go in the bottom, that's for the neutral, which would be this one. And then the black is going to go either on the XXX or the YYY. It can go either or, it's fine. The red wire is the same exact way. Because these are two of the hot wires, they can go in either one of these terminals, the YYY or the XXX. And then the green terminal, that's where the ground's going to go. Even though it's bare copper, that's where the green wire or the ground wire goes. So I'm going to go ahead and place the ground wire on first. And right here on the side is where the terminal is located. I'm now going to place the ground wire right into that terminal on the side. And then, because we got to torque these the specs, I got a torque screwdriver that I'm going to use, and it's set at 75 pounds per the manufacturer's recommendations. So I'm going to torque these screws down to 75 pounds as I make my connections. So I'm going to go till it clicks. All right, so that's at 75 pounds of torque. And because this is a solid copper wire, I don't have to wiggle the wire and then retighten it a few times. Just tighten it down once is sufficient. Now I'm going to make the connection with the black wire, and it's going to go right here in this bottom. And as you can see, the rest of them come up through the bottom of this receptacle. So now we're going to tighten that down to 75 pounds of torque. All right, it clicked. Now, because it's stranded, and stranded means there's multiple wires twisted together to make one, this is solid to where it's just one solid wire. Because of that, we're going to wiggle it back and forth a few times. And then after we wiggle it well, we're just going to tighten that up again. All right. Then I'm going to do it one more time, and do this 3 or 4 times should be sufficient. Just make sure you work the wiggles out of the stranded wire. All right. And now going to connect my white wire next and repeat that process. And then the last wire is the red wire going into this terminal. Now I'll move the camera around so you can see a little better. Now that we made all our connections, we're going to push this back into the box. And because this is 6 wire, it definitely takes a little fighting sometimes to get this pushed back, but as you can see, it's not that bad. I'm now going to take the 4 screws that came with the receptacle and place one in each corner into that mud ring to where we have the screw holes to connect to. And now I don't need my torque screwdriver for this, I'm just going to use my regular screwdriver. All right, we're nice and secure to the box, and I'm going to take the cover, and it's going to go right over it like so, and it's going to line up with the screw holes in each corner. I'm going to use the straight screws that came with the cover, and it's going to go right here. And again, like I mentioned, all this is to be done after the drywall. So once the drywall is done, it's going to be a nice flush mount So I just wanted to show you how to do all this even though the drywall's not on yet, so you can see all the roughing and everything. So I'm going to take all this back off, and I just wanted to do this to show you how it's done, then install the drywall, then I'll put all this back on afterwards. If you were curious where to install the outlet for your range, if you're watching this video to put this in for a kitchen, I just wanted to illustrate that it would be anywhere right behind the range on the wall. Typically I install outlets 16 inches up off the floor, but in my area there's really no code. I could put it down to 12 inches and it would be totally fine. So I just wanted to illustrate that installing this outlet for a range would be exact same steps with the metal 2-gang box, etc. Except I would use this cheaper Leviton and this smaller plate cover in order to finish it up. I'm now going to use these staples in order to secure the wire. Secure the wire within 12 inches of the electrical box, keep it right in the center of the stud, and use those wire staples. And nail it every 4 foot apart going up the stud. I'm now going to connect the other end of the 6-3 wire to the panel. And again, this is a sub panel, and I'm first going to kick off the main breaker, and then I'm going to take the panel cover off and install the breaker. And just a little note, even though the main breaker is off to this panel, the lugs underneath these lug covers are still hot, and I never make it a habit to touch this metal in the back regardless, because that's just the safety that I like to do when I open a panel. I gotta take the 3/4 inch knockouts out of the back of this panel in order to fish the 6-3 wire down through it. It may be difficult to see, but I got a 3/4 inch knockout here and one here. I'm gonna knock this one out in this far corner. I'm gonna take a punch to knock it out, and it installs just like when we installed one onto the 2-gang box. And I'm now just gonna grab it and finish it off with my linemen's. I'm now going to install the 3/4 inch Romex connector. Now that that's tight, I'm going to fish in my 6-3 wire. Before I tighten up that Romex connector, I want to finish stapling the wire to the blocks, and also make sure we staple within 12 inches of the sub panel. And with that being said, I got this block here and it's well within the 12-inch mark. So I'm going to staple it here, then staple it here. And I'm now going to tighten up my Romex connector. I'm now going to strip off the black casing off the Romex wire. I'm now going to unravel the wires and get the paper off the ground wire. I'm now going to fish this bare copper wire in behind all my other wires and land it here in this ground bar. I'm now going to cut this wire to length, and I'm going to land it right here, so I'm going to cut it about right here. I'm going to take my square drive and loosen up this ground terminal. I'm now going to take my needle nose, grab it, and place it into that terminal. I'm now going to take my square drive and tighten that to the ground bar. And just so you're aware, this is a sub panel, so I got to separate my neutral bar and my ground bar and put the wires separate. So I had to add this onto the sub panel when I did this. If you want to check out that video, check out the link in the top right hand corner of the screen, and I'll show you how I installed this sub panel. I'm now going to land this white neutral wire in this neutral bar. So I'm just going to fold it back, bend it in towards that bus bar, the neutral bar, and clip it right here. I'm now going to cut off about a 1/2 inch of the casing in order to install it, and I just got to scar around the wire first, and then it'll peel off. I'm now going to loosen up this neutral bar terminal and place it into it. I'm now going to tighten that up and then give it a good little wiggle and then tighten it again. It's important to do that with stranded wire because it takes a few wiggles to get it tight. I'm now going to install the double pole 50 amp breaker into the panel. All I got to do is hook it onto this plastic bar, and then the metal on this side of the breaker slides into the metal on the side of the panel. Right like so. And now same idea, we're going to bend these wires in and then fold them towards the breaker, then cut them the length. So about right here. And then same idea, we're going to strip off just about a little less than 1/2 of an inch off the ends of these wires. A useful tip to know is oftentimes on the back or the side of a breaker, there is a strip gauge located on it to let you know exactly how much to strip off the wire. Now that I got the wire stripped, I'm going to pop this breaker back out in order to make the connection. And something important that I wanted to show you, if you take a look on the side of this breaker, as you can see, it says it's to be torqued down to 45 pounds. I'm now going to use a torque screwdriver in order to make my connection, place the wires into this breaker. And it doesn't matter if you put the black at the top or bottom lug, or it doesn't matter if you put the red in the top or bottom lug of the breaker. As you can see, here's a 50 amp one I already put in, and you can see the red's at the top, but in this one I'm going to put the black in the top just to change it up a little bit. So we're going to slide it right into that terminal like so. And then I'm going to take my torque screwdriver that's set at 45 pounds and tighten this lug down. And I'm going to twist until it clicks. All right, so you heard it click there. So something really important that I do with stranded wire is we twist it and wiggle it back and forth a few times, and then we re-torque it down. And then again. As you can see, it got a little tighter each time I wiggled it. Now we're going to do the same with the red wire to this lug or to this terminal. All right, give it a little wiggle. Tighten that again. And one more time. Now that we know we are tightened correctly, we're just going to place the breaker back into the box. Now the breaker's installed, we're going to replace the cover onto the box. I'm now going to address the panel cover. I'm going to label the new circuit a 240 volt outlet. So that's going to take space 10 and 12. And now I need to break out the little areas here in order to compensate for the new breaker. And then we're going to reinstall the cover. And just real quick, I just want to go over with you how the adapter works with the charger in order to make your connection from the 240 volt outlet to charge your vehicle. So with Tesla, you have what is called a NEMA 1450 Gen 2 mobile connector smart adapter. And this can be found on Amazon like you see here. But I'd like to point out from their actual website, here it is if you want to see the exact website link. And then if we scroll down, as you can see, there's multiple adapters for different 240 volt outlets. And we got some that are for 30 amps, 20 amps, 15, 20, and 15 amps. And then if we take a look, here is the 1450 down here that we've been talking about in this video. And if we scroll down, as you can see, the 1450 and the 650 both charge the best because it's using 50 amps. As you can see, the 30 amp and this 30 amp is slower charging. And also, if you don't have a Tesla or looking to buy a Tesla and you want to get a third-party charger, all you got to do is look at something like ChargePoint. ChargePoint offers a charger that is designed to be plugged into a 240 volt outlet, and it also can be hardwired as well, just like the Tesla wall charger if you're not going to buy a Tesla or want the Tesla charger. So that are the options when it comes to using the 240 volt to charge your vehicle. After this building's insulated and the drywall's hung, all I have to do is reinstall that NEMA 1450 over the drywall, and then come over to my sub panel, open it up, kick on that 50 amp breaker that we just installed, And then we'll have power over there to charge our EV, run a heater, etc. Whatever we want to do with it, it'll be there. And if you're interested in learning how to install an exterior outlet that's GFCI protected, my buddy Scott from Everyday Home Repairs did an excellent job explaining that. Check out his video in the top right hand corner of the screen.